Objective factoring directions for problems 1 through 8 below. Factor each polynomial. All right, since number 13 says to factor x squared minus 6x minus 27, I am going to, since it is a quadratic trinomial, I know that it's going to be 2 parentheses with an x, and then remember we're going to take 1 times negative 27, which would give us negative 27, and then I'll be thinking to myself, what times what would give us negative 27? 9 times negative 3 times 9, negative 1 times 27. I'm going to stop because I wanted to get negative 6 in the middle, and whoops, I need another one actually. How about negative 9 times 3? Negative 9 plus 3 does give me negative 6, so I'm going to use this combination, positive 3, and then that problem is factored. Number 4, 2x squared plus 7x minus 15. I do notice it looks a lot like 13, so we are going to factor it the same way, except since it has 2x squared, we remember we'll put 2x and 2x, and then when I'm done I have to divide out that 2. So now I'm going to take my 2 times my negative 15 and get negative 30. And then what times what will give me negative 30? Negative 15 times 2, negative 2 times 15, negative 10 times 3, negative 3 times 10, negative, I think I can stop. I think I have my choice there. I want to get positive 7, so which one of those, when you add the two numbers together, will give you positive 7? It will be this one because negative 3 plus 10 is 7. So we're going to put minus 3 plus 10. I do need to divide the 2 out of one of those. I'm going to divide it out of the second set of parentheses because 2 will go into each term of that binomial. So just bring your 2x minus 3 down. And then here, 2 divided by 2 will just be x, plus 10 divided by 2 is 5. So that would be my answer on that part. The code letter for this video is I. Right, problem 15, we've got 25x squared minus 81. This one, again, is a quadratic, but this time it's a binomial instead of a trinomial. And I do notice that I can square root 25 and I can square root 81. So this is a 2 parenthesis problem. The square root of 25 is 5x and 5x. The square root of 81 is 9 times 9. One gets a plus, one gets a minus. So try not to make that one harder than it is because you'll just run into problems if you do. All right, number 16, 10x cubed minus 15x. All right, this one, I do notice that it's not a quadratic at all. So what we usually like to go to on this one would be a GCF. So I'd look at what number would go into both of those. What number would go into 10 and 15? That would be 5. And then if I have an x cubed and an x to the 1, I'm going to take the x to the 1. And then let's just divide both terms by the 5x. 10 divided by 5 is 2. If I subtract my exponents on the x's, I'll get x squared. Bring down the minus sign. 15 divided by 5 is 3. And since the x's are identical, they will cancel out. So that would be my problem factored. Okay, problem 17, we've got 6x squared plus 13x plus 6. This was similar to a problem we did just a few minutes ago. It is a quadratic trinomial, so I do know I get to put 2 sets of parentheses, and since it says 6x squared, we're going to put 6x and 6x. Before we're done, we want to be able to divide out that 6. Then I'll take 6 times 6, which would be 36. So what times what gives me 36? 6 times 6. 9 times 4, 18 times 2. I'm actually going to stop because I wanted to get 13. And 9 plus 4 does equal 13. So plus 9 plus 4. Now when it comes to dividing out the 6, I notice that 6 will not go into either of the parentheses because 6 won't go into the 9 or to the 4. So we're going to split it because 3 will go into 6 and 9. And 2 will go into 6 and 4, and 3 times 2 is 6. So we're just going to split it like that. So if I divide the first set of parentheses by 3, I'll get 2x plus 3. And if I divide my second set of parentheses by 2, I'll get 3x plus 2. So that's how that one would factor. Okay, last one in this section, number 18, 20m to the third n plus 8m squared n squared plus 12m cubed n cubed. Now this one looks like a weird one, and usually if it looks a little weird, we always want to start by looking for the GCF. So what is the largest number that would go into 20 and 8 and 12? That would be 4. And then if I have m to the third, m to the second, and m to the third, the smallest of those is m to the second. And then if I have n to the 1, n to the 2, n to the 3, the smallest one of those would be n to the 1. Okay, so we'll divide each term by 4m squared n. Okay, and the first one, 20 divided by 4 is 5. M to the third divided by m to the second would just be m to the 1. And then the n's are identical, so they cancel out. So then bring down your plus sign. 8 divided by 4 is 2. M squared and m squared, they're identical, so they're going to cancel each other out. And then if I have n squared divided by n, that will give me n to the first. Bring down your plus sign. 12 divided by 4 is 3. M cubed divided by m squared will be m. We're subtracting the exponents. And n cubed divided by n is n squared because, again, we're subtracting the exponents. And that would be that problem factored.